Welcome to your Get That Nugget for GCSE Maths. Today we will be concentrating on giving you a framework to answer grade 4 factorising single bracket style questions. Please note, this session is to complement your lessons with your teachers. It is not to replace them in any way. So let's have a little look at what we mean by factorising. So we won't necessarily do all of those examples, just do a couple, and then we'll start to build on this. So factorise is the reverse of expanding. So we're looking to put an expression into brackets. So if we write this one down, we're looking to factorise 2x plus 8. So when we think about factors, we're looking for common factors, things that appear in each of these terms. So the first thing you want to do is look at, okay, I've got new numbers here. So if we think about the number 2 and the number 8, what's a common factor? What times tables are they both in? That's what we mean by factors. So actually, they're both in the 1 times table, but they're both also in the 2s. So when we come to factorise, we're always looking to try and give the biggest factor that we possibly can. So in this case, the biggest factor of 2 and 8 would be 2. 2's in the 2 times table, and 8's also in the 2 times table. We'll then look at any other terms in the expression. Well, I've got an x here, but there are no other x's over here, so I can't take anything else out. So what we do is we open our bracket because that's the only factor that's common in both. 2 lots of what are going to give me 2x? Well, I've already got the 2 as a factor, so that's going to be an x. And we've got to be really careful for the next bit. Remember, we're always multiplying. So 2 multiplied by what is going to give me 8 because we've taken out the factor of 2. Well, 2 times 4 is going to give me 8. So that's how we would factorise. We put it back into brackets. If we have a look at the next one, I've got 6g. And we're looking to factorise 6g minus 18. So it's going to be the same process as before. We're going to look at numerical term if we can first. So what times table, or what are the factors of 6 and what are the factors of 18 in terms of which factors they share? Well, they're both in the 1 times table. They're both in the 3 times table, but they're also both in the 6s. And again, we're always looking to pick the biggest factor. So the biggest factor would be 6. I then look at letters if I can. Well, I've got a G here, but there's nothing else over here. So I can't take another factor out because there's no common letter. So we open our bracket. Well, I've got 6. 6 multiplied by what gives me 6g? Well, that's going to have to be g. I've got my subtraction here. Well, 6 lots of what? Or 6 multiplied by what gives me 18? Well, that has to be 3 because 6 times 3 would be 18. So they're 2 expressions that factorise. Fairly straightforward because they only have a common factor of numbers. That can share. So let's have a look at trying to up the ante or make the difficulty a little bit more. Let's look at this one. So it almost looks we've got quite trickier quite quickly. But if we can do the numbers, I'm fairly sure we can do when there's other common terms as well, common factors as well. So I've got 8f cubed and I'm subtracting 2f squared. So first thing, have we got any common numerical terms? So we've got an 8 and a 2. What's the biggest times table? What's the biggest factor of 8 and 2? So what times table's got 2 and 8 in it? Well, it has to be 1. And it also has to be 2 because they're both in the 2 times table. So the biggest factor is definitely 2. We're then going to look at our letters here. I've almost changed them into pound signs, but hopefully you can see that I've got f cubed and I've got f squared. So in essence, I've got almost what we could say is 3 f's here, f times f times f. And here I've got f squared, which is f times f. So in terms of what's common in both, well, actually, I've got f squared here and I've got f cubed here. So I can take out a common factor of f squared because both of them can contain at least f squared in them. There's just an additional f here. So then I can open my bracket. Well, I've already taken a common factor of 2. What do I multiply 2 by to get 8? Well, that's going to be 4. Now I can see I've got f squared, but I want f cubed. So I need to multiply it by another f, because that would then give me f cubed. So this needs to be f. 2 times 4 gives me the 8. F squared times f gives me f cubed. I've got a subtraction here. And this is a little bit tricky. I've got 2 and I've got f squared. So what do I multiply 2f squared by to get 2f squared? Well, if we think back a couple of examples, if I want to multiply something to get the same thing, then I just need to multiply it by 1. So if you check again, 2 times 4, 8, f squared times f is f cubed. 2f squared times 1, or times minus 1, is going to give me minus 2f squared because the value won't change. And we'll have a look at another one of those. I think it's easier, but it's just, I don't want it to catch anybody out. What if we've got 5g cubed plus g squared? So we're looking to factorise this expression. 5g cubed plus g squared. Well, if we look at the numerical, the coefficient, I've got a 5. There's no other number in the second term, so I can't take out any factors that are greater than 1, so I can't take any numerical factors. So then we look at the g cubed and the g squared. Well, similar to our previous example, I've got g times g times g, and here I've got g times g. So in effect, I can take out as a factor g squared from both. So I can put g squared on the outside. I open my bracket. I've got a 5 in front, which I don't have here, so I need an additional 5 to go in the front. I can see that I've got g squared, but I want g cubed. So I need another g. I need to multiply this by another g to give me g squared, g cubed. The sign in the middle is plus, and you notice that classic situations arise again where I've got g squared already and I want to get g squared. So I just need to multiply it by 1. So that's how we would do those type of examples. Now, in terms of upping the difficulty a little bit, what about this one? Now, I've chosen this one because what you'll find is it's making sure we pick the biggest factor. So 30x cubed plus 12x. So we're going to look at those numbers first. 30 and 12. What is the biggest times table they're both in? What is the biggest factor of 30 and 12? Well, I know 1's a factor. I know 2's a factor. I know 3's a factor. I also know 6 is a factor. So in essence, I want the biggest factor for those. So I know the biggest times table they're both in is going to be 6. I then look at the letters if there's a common letter in both. And I can clearly see I've got an x cubed and I've got an x. So this is x times x times x, and this would just be x. So I can take out a common factor of a single x. I can't take any more than that because I only have one x over here. So then I've taken out all the possible factors I can. So I open my bracket. What do I multiply 6 by to get 30? Well, how many 6s are in 30? That's going to be 5. I've got x, but I want x cubed. So I need another 2 more effectively because I've only got 1 here. So that means I need to multiply it by x squared because 6 times 5 is 30. X times x squared is going to give me x cubed because I'm going to multiply 3 of them. There's a plus. I've got 6. I want 12. What do I multiply 6 by to get 12? Well, that has to be 2. I've got an x. I want an x. Do I need another x at all? Definitely not. So I've already got the letter I need. It was just that 2 to get it to 12. So that is that one, factorised. So that's more common. It's a little bit more tricky. Need to choose the highest factor, and we've also got letters. And then I've thrown this example in here because sometimes it throws people a little bit. I've got 3 terms. I've got 10a. So I've got 10a plus 20b, but that's a plus 30c. So first thing, I'll zoom out a bit because this is a little bit of a bigger example. I can see the numbers 10, 20, 30. In terms of a common factor, what's the biggest times table that's got 10, 20 and 30 in it? I know they're both in the 1s. I know they're in the 2s. I know they're in the 5s, but the biggest times table, the biggest factor has got to be 10. Look at the letters. I've got an A, a B and a C. They are clearly not the same. So there's no common factor of a letter that I can take out. So now I open my bracket. I've got 10. I just need to multiply it by A. The signs are going to be a plus. Got 10. I need to multiply it by 2 to get 20. But I also need the B. Then I've got a plus. What do I multiply 10 by to get 30? Well, that's going to be 3. And then we mustn't forget 3C. So the same process. I just didn't want to throw you in case you saw 3 terms in an expression and panicked a little bit. Just still looking for the same common factors and then building from there. Okay, and then what we're going to do is I'm going to look at this as a final example because there are cases where there's more than one letter in a term in an expression. So we've got 4a cubed b to the power of 5 plus 12a squared b cubed. The process is the same. Do it step by step. So I can see I've got numbers here. So again, looking for common factors of 4 and 12. Well, they're both in the 1 times table, they're both in the 2 times table, but they're also both in the 4 times table, and 4 is the biggest factor, so we want the 4. We'll then look at any common letters they might share. So I can see here I've got A's, which is great. So I've got A cubed, again, which means A times A times A. And over here I've got A squared, which means A times A. So I can take out A times A from both of those because they both contain A squared. So I can take out an A squared. I'll then look at B's. I've got B to the power of 5. And I've got B cubed. So B times B times B times B times B, and then B times B times B. So actually I can take out effectively 3 of those B's. So I can take out B cubed. So I can take out quite a lot of common factors in this question. And that's all I've got. There's nothing else. I've underlined everything I can. So I'm going to open my bracket. I've already got my 4, so I don't need to multiply 4 by anything to change the value. However, I've only got A squared and I want A cubed. So I'm going to need an additional A to multiply by. I've got B cubed, but I want B to the power of 5. So I need 2 more. So I need a B squared because remember we add to get the powers. So B cubed times B squared is B to the power of 5. Sign in the middle, going to remain a plus. I've got 4, I want 12. How many 4s are in 12? Well, that's going to be 3. I've got A squared, I want A squared. I've got B cubed, I want A B cubed. So I don't need to add any additional letters on the end. That is it factorized. So I can close the bracket and I don't need to go any further on that one. So slightly tricky, but again, same principle. Look at the numbers, look at the common letters and try and take out as many factors as we possibly can. So let's leave you with a few questions to try. These are your questions that you're going to want to look at. So it's all about factorizing all of those expressions. Just be careful with your signs. If you've got a subtraction, make sure we've got the negative in there if we need it. And have a go at those.